Class, please stand up. Glenn, please lead the prayer. Amen. Okay, good morning class. Before you take your seat, kindly pick up the pieces of paper under your chair and arrange it properly. Okay, you may now take your seat. Winston, is there any absent today? Okay, very good. Give yourself a round of applause. Okay, Francine, do you still remember the topic that we had discussed last time? Okay, very good. Okay, class, before we proceed to our discussion for today, I want you to watch this video first, and later on, you will give an insight about it.
What do Euclid, 12-year-old Einstein, and American President James Garfield have in common? They all came up with elegant proofs for the famous Pythagorean theorem, the rule that says for a right triangle, the square of one side plus the square of the other side is equal to the square of the hypotenuse. In other words, a squared plus b squared equals c squared. This statement is one of the most fundamental rules of geometry and the basis for practical applications like constructing stable buildings and triangulating GPS coordinates. The theorem is named for Pythagoras, a Greek philosopher and mathematician in the 6th century BC, but it was known more than 1,000 years earlier. A Babylonian tablet from around 1800 BC lists 15 sets of numbers that satisfy the theorem. Some historians speculate that ancient Egyptian surveyors used one such set of numbers, 3, 4, 5, to make square corners. The theory is that surveyors could stretch a knotted rope with 12 equal segments to form a triangle with sides of length 3, 4, and 5. According to the converse of the Pythagorean theorem, that has to make a right triangle, and therefore a square corner. And the earliest known Indian mathematical texts, written between 800 and 600 BC, state that a rope stretched across the diagonal of a square produces a square twice as large as the original one. That relationship can be derived from the Pythagorean theorem. But how do we know that the theorem is true for every right triangle on a flat surface, not just the ones these mathematicians and surveyors knew about? Because we can prove it. Proofs use existing mathematical rules and logic to demonstrate that a theorem must hold true all the time. One classic proof, often attributed to Pythagoras himself, uses a strategy called proof by rearrangement. Take 4 identical right triangles, with side lengths A and B, and hypotenuse length C. Arrange them so that their hypotenuses form a tilted square. The area of that square is c squared. Now rearrange the triangles into 2 rectangles, leaving smaller squares on either side. The areas of those squares are a squared and b squared. Here's the key. The total area of the figure didn't change, and the areas of the triangles didn't change. So the empty space in one, c squared, must be equal to the empty space in the other, a squared plus b squared. Another proof comes from a fellow Greek mathematician, Euclid, and was also stumbled upon almost 2,000 years later by 12-year-old Einstein. This proof divides one right triangle into 2 others and uses the principle that if the corresponding angles of 2 triangles are the same, the ratio of their sides is the same too. So for these 3 similar triangles, you can write these expressions for their sides. Next, rearrange the terms. And finally, add the 2 equations together and simplify to get ab squared plus ac squared equals bc squared, or a squared plus b squared equals c squared. Here's one that uses tessellation, a repeating geometric pattern, for a more visual proof. Can you see how it works? Pause the video if you'd like some time to think about it. Here's the answer. The dark gray square is a squared, and the light gray one is b squared. The one outlined in blue is c squared. Each blue outlined square contains the pieces of exactly one dark and one light gray square, proving the Pythagorean theorem again. And if you'd really like to convince yourself, you could build a turntable with 3 square boxes of equal depth connected to each other around a right triangle. If you fill the largest square with water and spin the turntable, the water from the large square will perfectly fill the 2 smaller ones. The Pythagorean theorem has more than 350 proofs, and counting, ranging from brilliant to obscure. Can you add your own to the mix?
So class, what did you observe and what is your insight after watching this video? Glenn. Oh, nice. Bien. Oh, very good. Mutoto. Nice. All of your answers are correct. So let's proceed to our topic. Our topic for today is all about the 6 trigonometric ratio. But before we proceed to that, here are the objectives of the lessons first. Okay, number 1 is define trigonometry. The next is what are the 6 trigonometric functions? And you are going to define it. And the last objectives is cooperate in the group activity. You are all expect to do that after this lesson. So before we go on to our topic, I want you to give my 2 pick-up lines about trigonometry. Okay, number 1. Trigonometry ka ba? Kasi lagi mo ako sinesekten. Okay, number 2. Dalawa lang ang mararamdaman mo pag nag-aral ka ng trigonometry. Ano yon? Edi, soka, tuwa. Okay, let's move on to our topic. Do you have any idea about trigonometry? Oh, Nick, why are you laughing? Do you have any idea? Okay, stand up. Okay, good. Maris, what is your idea about trigonometry? Okay, all of your answers are correct. Let me define what is trigonometry first. Trigonometry comes from the 2 Greek words. The first is trigonon, which means triangle, and metron which means to measure. And this is a branch of mathematics concerned with the specific functions of angles and their applications to calculations. And that is trigonometry. Okay, number 2. What are the 6 trigonometric identities? Give at least one. Hutok. Okay. Predo. Nice. Alvin. Okay. Jeffrey. Okay. Very good. You got it. Okay, the 6 trigonometric identities are the sine, cosine, tangent, secant, cosecant, and cotangent. Okay, number 3. Give the trigonometric identity with its trigonometric ratio. Okay, number 1. The sine. What is the trigonometric ratio of the sine? Gilma. Good. What is the trigonometric ratio of the cosine? Aret. Okay, good. Number 3. What is the trigonometric ratio of tangent? May? Oy, boys at the back. Why are you laughing? What is cosecant? Sadie, what is the trigonometric ratio of cosecant? Okay. Thanks. All of your answers are correct. In the trigonometric ratio of the sine is opposite over hypotenuse. In cosine, adjacent over hypotenuse. In tangent, opposite over adjacent. Cosecant is hypotenuse over opposite. In secant, hypotenuse over adjacent. And cotangent is adjacent over hypotenuse. Okay, do you understand? Do you have any questions, recommendations, bio introductions, or any opinion? Okay, if there's none, let's proceed to our activity today. But before we proceed, I want you to group yourself into 3. Okay, starting from you, Glenn, up to Sadie, and Maris, up to Fredo. Okay, count. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. I want you to assign a leader per group. And the leader will come here to pick one piece of this paper. And this paper have an illustration of a triangle. And all of your members will participate to answer the problem here. You are going to identify the 6 trigonometric ratio in the illustrations of the triangle. Okay, proceed. Hop. Wait. Before you proceed to your activity, I want you to give the criteria first. Okay, number 1 is the presentations. Is the way how you present your work. Solution is 40%, 10% is for the cooperation, and 20% is for the creativity. Okay, proceed. Okay, present your work. Who wants to volunteer? Okay, no one wants to volunteer. Okay, I'm going to choose the group of Maris first. Okay, present your work. Okay, very good. Group 1. Okay, let's give them a nice clap. Okay, proceed. Group 2. The group of Glenn. Please present your work. Okay, very good. Very good, Glenn. Okay, class, give them a Yahoo clap. Okay, proceed. Group 3, the last group, the group of Sadie. Please present your work. Okay, very good, Sadie. Okay, class, give them a 1,000 clap. Okay, very good. Class, I want to congratulate you all for a job well done. But it's not over yet. I will give you a set word. Okay? Get 1/4 sheet of paper and answer the 5 problems here. Okay, class, time is up. Kindly pass all your paper forward and to the center. I think you got it all correct. Good. Okay class, get your notebook and jot down your assignment. So your assignment is, what are the special angels? Okay. So okay class, just remember this. A simple quote. No one ever accomplished anything great by playing it safe. Always remember that. And that's all for today. Thank you.